All right, guys, I think we'll go ahead and get going. So trickle in, find a spot, grab some
Before
food.
introducing
And welcome to the Utah Go Group for May. My name is Brandon. I'm one of the co-hosts running, so I'm going to just introduce the speaker today. As a heads up, microphones in this room are really good. So if you have whispered conversations in the back, you'll end up in the YouTube video and we'll all be able to hear you. And if you don't want that, then just be mindful of the big green boxes above you because they will try and pick you up. It's great for questions though, so you won't need your questions repeated, which is nice. If you want to speak here, there is a paper call link that you can go to. We're not that formal. If you're interested in giving a talk about one of the standard lib packages at Go, you can talk to me, Mariah, Carson. We're all happy to get you set up. We have the Forge Utah Slack is probably the best place to do that, or you can just come talk to us after the presentation today. We really want to encourage people who are maybe new to speaking, don't have as much experience with it, get an opportunity to get used to it. Obviously, if you have experience, you're welcome to speak too. But yeah, consider speaking. We also have, I don't know if I left this slide in. We have Go West coming up in the fall this year. Call for request for papers is still open, I think, until June. Yeah, so if you're interested in speaking at one of a bigger Gopher conference, consider submitting to speak there. It's always fun. We always have a good time. And then also Palmer with DevOps Days. Did you want to do your announcement?
Yeah, I just wanted to invite everyone to DevOps Days, which is Monday and Tuesday this week or next week. It's Salt Lake City DevOps Days that we have every year. We didn't have it last year, but we're doing it this year. We have great speakers. Carson's going to do a workshop there. A lot of AI presentations. Go to our website, see what the sessions are. Salt Lake City DevOps Days. And we have a code. So here's two codes: flash sale, case insensitive, or Go 2025. It's regularly $99. That's 80% off. So $20 for a 2-day conference, great workshop, and 2 lunches. So that's a pretty good deal. Register. I think prices go up on Monday, but trying to fill the hall. It's going to be at the Miller Conference Center there in Sandy. And Monday and Tuesday should be a great conference. So thanks for letting me present that.
Yeah. Yeah, thank you. We're always excited about local stuff. And like you said, Carson's speaking. So if you've heard his talks before, he does a really good job. Definitely go check that out. Jobs and hiring. If you are looking for a job, if you want to network, you think you might need a job at some point in the future, Forge Slack is a great place to do that. Also, if you're looking to hire people, there's a channel there where you can reach out and see if people have the skill set you're looking for. So with that, we're going to go ahead and move forward into the main event. We've been talking about Go standard library packages this year. And so we're going to turn the time over to learn about Go standard lib, the errgroup package. So I'm going to go ahead and stop sharing, and then I think that you should be good to.
Before I share, can you hear me okay?
You should be good to take over.
No, can you hear me okay? Or,
Yeah.
Okay. Thank you everyone for coming to my talk. So I titled this in a funny way. So how to have a sane weekend with Golang error groups. It's a pretty simple package under the hood, but doing it correctly, it will help for all the Go engineers to have a sane weekend. At least it helped me and Alan Pearl at Route to have a sane weekend. He's on the call as well. So quick intro about me. I'm Venkata. I'm currently working as a senior engineer at Clinia. Although I'm in Canada, but I was in Utah for 2 years. That's why I'm speaking remotely. And we are also, I'm hiring for like a lot of positions. I'll post that in the jobs wanted channel. If you are interested, hit me up. Uh, so let me see. Okay. So I want to start with what is concurrency. So I have two definitions for concurrency. So one is a textbook definition, and the other one is a guidebook definition. So the textbook definition is concurrency allows your program to perform multiple tasks simultaneously. The dad book definition that I want to explain to a 5-year-old, if I want to, is imagine asking 5 toddlers to clean different parts of your house at the same time. Some might succeed, some will cry, some will fight, but they will do it all at once. So that's like a good example that I actually tell like in simplicity. So concurrency in Go. So Go, luckily, is like a very simple language, and concurrency in Go is like managed via Go routines. So in this example here, there is a function called a function. It's a regular function, but adding a Go keyword right in front of it turns it into a concurrent function. And the good thing with Go is like they say in Google, if you like start learning the languages, like you can spin up as many Go routines as you want with that simple keyword. But a gotcha with Go routines is that when you turn a regular function into Go routine, and when you run that function, the main thread or like the main function will not wait for the Go routine or the function that is actually concurrent to complete. So that's why there is a way to kind of wait for Go routines to complete. It's called wait groups. It's part of the sync package in Golang. The easiest explanation would be like it's like a strict parent making sure all kids finish their chores before anyone gets a dessert. So basically, if you are spinning 10, 15, 20 Go routines, and if you want to wait for every Go routine to complete, you essentially use a wait group. So this is a quick example. So in this function, or in this example, we are creating a wait group, and we have 3 kids, Alice, Bob, and Charlie. So we are telling all these 3 kids to do some chore, and that function, and we define it using the function called do chore. And as we assign chores to these 3 kids, we create a checklist, you can say, using wg.add. So we are essentially keeping track of like what are the tasks that are assigned to Alice, Bob, and Charlie. And wg.wait, we are telling the main thread to wait until all the Go routines or all the kids to complete the chore. And how do we know that? So if you see the do chore function here, in the first line, it says like wg.done. So whenever a kid or a function completes their chore, it says like wg.done, essentially saying to telling the wait group that like, hey, my work is done. So once all the 3 kids say that like my work is done, the wg wait will continue to the next step where we say like we print all chores are done and all kids can have the dessert. But there is a catch in this one. So if one kid fails, we don't, sorry, if one kid fails, we don't wait, we wait until all other kids finish as well. So sometimes in scenarios, we say like we spin 10 Go routines, and if one Go routine fails, we want all the 9 Go routines to stop as well. So that is not actually possible with this sync.wait group. The other issue is that whenever a Go routine returns an error, like a function can return an error, it happens. And with this approach, we cannot know like which Go routine or which Go function has failed. So if someone is new to Go, there are 2 ways that one can say like, this is how I would handle errors in wait groups. The first way is adding an error variable in front of the do chore function, but that is invalid syntax in Go. That's why the squiggly thing happens. The second way is wrapping the do chore function inside a closure and kind of returning an error. Here, if the do chore function returns an error, we return it to the closure, but like nothing is kind of like catching that error. So to kind of catch errors, one hacky way, or it's I shouldn't say hacky, but it's like unclean way, in my opinion, is using a channel. So basically, you create a channel, and whenever Alice, Bob, or Charlie return an error, we kind of send that error into the channel. And after that wg.wait, we kind of iterate through that channel and see like which kid threw an error. If you see, it's not clean, and there is also like you have to like manage this extra channel to kind of like handle the errors. So enter the savior. So we kind of came across this package at Route when me and Alan actually were working and resolving. So error group is wait group, but it is smarter and with error handling and cancellation, context cancellation baked in. So the same example, we can rewrite it using error groups in the following way. So we create an error group G, and for each kid that we want to assign a chore, we do like g.go and pass it in a closure. And that closure, we can pass any function in there. So in this example, I'm actually modifying the do chore function to return an error instead. Previously, it wasn't returning an error, and it was also taking the wait group as a parameter. So the kids complete the chore, and if they have an error, they send an error, otherwise they return null. And down below, we wait for all the goroutines to complete. And we also capture the error here, which we were not able to do before. We just do like wg.wait. And if they fail silently. But now we are actually capturing the error that do chore returns or any of the kid returns. But there is a problem. So looking at the docs, the error group.wait function will only return the first error from a bunch of goroutines. Let's say you have Alice, Bob, and Charlie. And let's say Alice succeeded with their chore, Bob failed, and Charlie failed. But when we look at the error, we only get the error from Bob. We don't capture the error from Charlie. So that's the gotcha with error groups. The other problem is that if Alice fails, wait group will wait till Bob and Charlie complete. So essentially, till all the goroutines complete, the wait doesn't like move forward to the next code path. So sometimes it is okay. Like for example, there can be scenarios where failure of one goroutine shouldn't interrupt other goroutines. But in some scenarios, failure of one goroutine to interrupt all the other goroutines that are doing their work. In the case of Alice, Bob, and Charlie, if Bob fails, Alice and Charlie should go and attempt to see like Bob, like, hey, what happened? Like, what did you fall down or did you hit your head or etc. So with a small change to the error group initialization, we say like error group with context and we pass a empty context. So that returns us a error group struct and a context that can be like thread safe. So now we modify the do chore function to take in a context and the kid's name. Now, if Bob fails, Alice and Charlie will get a notification if they are listening on the context.dump. So, which is really useful if on one error if error on like one goroutine should interrupt all other goroutines. So gotchas to keep in mind, I kind of already talked about it. I'll probably summarize this. So plain error group doesn't cancel other goroutines. So on error, it will only return the first error. but it will wait for all the other goroutines to complete. The last thing is when using error group with context, if you do not listen on context.done, the same thing happens where it will wait until all other goroutines to complete. If you listen on context.done, when error happens on any goroutine, it will interrupt all other goroutines as well. So yeah, that's it for this talk. It's pretty simple package. Yeah, any questions? Yeah, you can ask me. So much data, we have 15 minutes. Carson.
Yeah, any questions?
I have one.
Mhm.
So let's say Bob fell asleep, or I don't know, Charlie decided to go and clean the home next to your. How long the parent can wait? Are there any way to say like it doesn't have to take longer than this? Or and the second question is there a way you can say which specific routine I'll allocate different time to every routine? So
The
the
first,
A should.
yeah.
Yeah.
For the first question, when you pass context, I was passing like context.background, but you can pass context.timeout with timeout. You can say like, you can specify a timeout that like in 10 seconds or like 1 hour, you should finish all the chores. So when you do that, when you pass that timeoutable context, you will get a cancel method with that, and you can cancel it, or you can call cancel whenever timeout happens. Or I correct myself. You pass a context with timeout, and you kind of like the context will cancel whenever the timeout elapses. For the second question, I don't know. If someone else knows.
I have a question, if you don't mind.
Mhm.
What are some good real-world use cases for this?
So let's say I'll talk about a use case that I was working this morning in my current, it's safe to say outside. So whenever we try to, like in my current role, there were two scenarios where whenever a request comes in, I actually send a message to it, like an SNS topic, and I also create a entry in the database. And both tasks are kind of like independent. They don't wait on each other. And I use this error group to say like send a message to SNS topic, create an entry in the database. So that's like a good example.
I have a second one. I think it's worth bringing up. I'm going to ask you to do, if you don't mind, I don't have my computer with me. Could you pull up the Go docs for the error group package real quick and
Yeah.
pull up examples? I think it's really illuminating to see
Okay.
the examples in that package illustrate like a lot of really, really helpful use cases.
Yeah.
You already have.
Okay.
So if you'll pull up just the parallel example. Yeah, and then zoom in just a little bit. I think this illustrates my personal favorite use case of this to further answer that question. Real life use case for error group that we have is we have like app resource generation, right? We have a bunch of files that represent the state of all the applications we want deployed at Weave. And I can go out and gather, here's the 1,000 configurations that I need to generate. And the system could generate them in parallel. So I need to go out and I've got like 1,000 documents I need to iterate through. And I want to run them in parallel, but I also want to capture the result of each of the 1,000 generations that I'm doing in parallel. You can do that with Goroutines and channels and have a huge headache. Trust me, I've done it that way, where you make multiple channels and you're spinning them off into Goroutines, and you're feeding them back onto a channel and using a second channel for signaling to let you know when all the things are done, or using a wait group for signaling. But this, I think the parallel example really illustrates, like, if you need to, you've got a list of things you want to run again, 100 of these processes in parallel, and aggregate all the results in, and not have to kind of get yourself stuck in channel purgatory. Error group combined with, and I think this is incredibly clever the way the example shows you how to do this. You pre-allocate a slice for the results, right? You say, I've got 1,000 things. I know that I've got 1,000 things I'm going to run in parallel. Maybe not 1,000 at once, but I'm going to run, up to X number concurrently, and eventually go through all 1,000. Pre-allocate a slice that says, well, there's 1,000 spaces in this slice where I can put a result. And then spin off these. You just call again. You don't have to worry about the parallelization. You do that when you initialize and you create the error group. It actually is in the run, isn't it? Where do you say the concurrency? There's with context, and then there is a way to change the concurrency. I think that's a separate method on the error group.
Yeah, I think it's called
Set limit.
set limit. Yeah.
So you say, I've got 1,000 things I need to run. Run up to 10 of them at a time. I don't, as soon as one's done, throw another one on. So I have at least up to 10 of them running at a time. And I've pre-allocated 1,000 slots, and I spin them off. And each one of those things knows that when it's done, it just, it's memory safe to just insert at a specific position. You can have multiple Goroutines as long as they're not trying to insert to the same place in a slice. It's fine. So you say, spin them all off, and when this one's done, it's going to insert into position 1, and the next one's going to insert in position 2. And that basic example that they had for parallelization makes it really easy to do something that is otherwise in a lot of languages really complicated, which is I need to go through 1,000 of these things and capture the results, doing up to X of them in parallel. And this, what is that? 30 lines, there's 20 lines. I'm bad at counting lines like that. But that's a really, really small number of lines to do what would be really complicated, even in Go, otherwise. So that's my favorite use case, is when you have stuff you want to do in parallel. That's great.
I have a question.
Huh?
Like in other languages, I'm thinking something like functional. You would do this sort of stuff with streams. So you would say like, hey, I have 1,000 items. I want to work on 20 at a time. And you would write it as kind of as pipes. So do this, then that, then this, right? And it will be kind of functional. The thing that I noticed is that the Go function, it only returns an error, or whatever the other function was. It only returns an error. It doesn't return a result, right? It's so everything that will require a result, right? If it's not just a write only thing, you would have to have a mutable variable and manage kind of all of that. It's why doesn't, compare that to even JavaScript, right? Promise.all returns an array of results, right? You don't have to create that array and worry who is going to update it at what point and all that stuff. Why don't you have this more data oriented API for this?
I think there are other packages that provide stuff like that. I don't have them just in my head offhand, but I've seen other parallelization, fan in, fan out, packages that do that in Go, right? So the core language itself tries to really limit it. It actually provides a ton. The whole point of the standard lib series of talks is how much there really is shipped with the language. But they do draw some lines if there's not a very clear, obvious, correct way, or if the community is not centralized on this is how we do a certain thing, then it won't be shipped with the. So they have stuff like that. But I think it's just not the core language because there's too many opinions on what the right or wrong way is.
Yeah, thanks.
Yeah, this isn't maybe as intuitive as on the JavaScript stuff, but if you're doing it in Go, this is more intuitive than in other ways you might try
Well,
to do.
JavaScript, it's harder to do the limit to the this number of concurrency. It's possible, but just not as kind of ergonomic. But it is easy to do 3 things, but then it works great.
Yeah, and I think the power for me is the concurrence, using the Goroutines in this really efficient way where you don't manage them at all. Because without this, it's really easy to go to say spin off 1,000 Goroutines and have them all run at once and just fight over resources. But it's much harder to do that kind of limiting. And if you paired this with other channels, right? If you had all these Go routines feeding into other channels, you could kind of, like I said, you could kind of build more advanced pipelines like you're talking about, but.
Yeah, I think the thing that like this example in itself is really narrowed to just like error handling. I would not say it's a full example of how concurrency works in Go, because every time, like you can see right here, where they have in that select statement with the cases, every time they say how concurrency works in Go, it's very channel heavy. And that's actually where the data structures in Go, like the data management in Go is typically defined with concurrency. So like, I think it's more the example there, like, but yeah, I will say the way they ignore race conditions in Go is by trying to remove those kinds of the objects from the Go routines, right? Can we make them be outside so that we just have to essentially lock them and not have to deal with it too much? Like you gave the first class function talk also on how they like, that's another way they do that with doing first class functions and other things to kind of keep things out in a separate context to try to avoid just like essentially all you have to do is a mutex lock and not do any passing. Like, so it's just weird. Concurrency and Go is like, yeah, it's easy and it's good. You don't have to manage it. And it's like, but I don't know. I think the code immediately gets harder to read as soon as you want to leverage concurrency and Go, and harder to follow. Like, great, we don't have to manage anything, but now we can't read what we're doing. So there's trade-offs.
So I think there's, yeah, if I were to like restate and simplify that statement, I would say, yes, channels in Go are one of the best things and you probably don't need to use them directly. And that's an example of that.
Yeah.
This uses channels a lot under the hood and you don't have to think about it all. You just write what it feels like linear programming, but you leveraging, just like the Go HTTP server, right? The Go HTTP server is using channels all day long, but you never see them once. Yeah, this is one of those things that if you probably don't need it at all in Go until suddenly you really need it, and then if you I think it's good just to know that it exists, because this will save you hours of trying to do something like this with multiple channels. You'll keep adding channels to try to solve problems that other channels have introduced, and you'll get into Mariah's like, yeah, cycle of concurrency and channel health, and
Hey, I haven't done that yet.
the one you were describing.
Yeah, sorry, yeah. The
Not
one
the
I
one
was
you
imagining in my head.
So anyway, yeah, I think that's the main use case for this package specifically.
Is there any particular reason that it only returns the first error? Like that?
Example?
Yeah, the error group just returns the first, which sort of surprised me. I figured it would return a slice because it doesn't exit after the first error, so it sees all the errors. I'm just curious if there's any insight in the group as to why that design decision might have been made.
I don't know.
I'm sure they're trying to do some weird fail fast thing and
That's
it doesn't make
probably
any
it.
sense.
Probably it.
Honestly, I think it's just like, generally speaking, it's a fail fast pattern. And other than that, they'd be like, but if you ask them to go implement it in production, like, we'd never do that. Like, their examples are so canned. It drives me insane. Sorry. I get really.
You can't see, that sucks to
You would see it.
see the rest of that comment there. All right, Venkata, I'm gonna ask you for more help. Can you read the rest of that message that was just posted? I'm really failing today by not having my laptop.
No worries. So Arjun Sharma is asking, what are some limitations of working with this library, and have you observed any performance bottlenecks? Performance bottlenecks? No, I did not personally. Limitations, as someone just said, like capturing results is one limitation. But the first error, only the first error is returned is another limitation. But other than that, no, it's just like a wrapper, a nice wrapper on the simple groups also.
That sounds exactly right to me. I would say you could probably leverage in that parallel example that it had, where you're getting the results from all the URL scraping or whatever it was, you could take that exact same pattern and also just create a slice of all of the errors that have happened.
Yeah.
So if you really needed to get all the errors, you could do this and just where it says results : make slice. You could also just make a slice of errors and also have every single goroutine stick its error into a position in a slice. So it's probably defaulting to the first just for exactly Mariah's guesses. Like we're all just guessing, right? I don't know.
Yeah.
We'd have to talk to who wrote it, but for fail fast by default reasons and use fewest resources by default. But you could, in theory, use this same pattern to get results and errors
For all of those, yeah.
Which, I don't know. I guess the only time I've ever considered error handling in a goroutine is either, the only thing I want to do is essentially log, like I don't ever want to do any kind of panic or take any action on it. I'm just kind of like close the goroutine and move on to whatever's next. Like I mean, I really try to avoid too much orchestration with that pattern. I don't know. It's just a weird, just like personally speaking, I feel like it messes with my head too much as far as flow. So I guess I can't think through it. Yeah.
If you're spinning off a goroutine, you can return. There's no return from a go.
No, I'm
right?
saying, but this
So
essentially
you-
is how, like, using an error group, you could access the error outside
Yes.
of the goroutine, which is how I was conflating the term return with that. But essentially, yeah, because you can't return, it messes with my head. And I'm like, I guess I'll just log.
The only way,
Like,
the only way to get an error back from a routine you spin off is to use a channel. Right? And this is a better way of doing, even if you didn't need parallelization, this might be a better way of getting an error back from a goroutine that you're spinning out, rather than like the normal thing of pick an error channel and read from it and remember to close it. Like there might be an argument to using error group, even if you just have
I
one,
I
that you're
think
running a
there-
no
if-
parallelization.
I think there is if you need to handle the error.
If you need to handle it.
With I like to avoid. I like I want to just log in and
You just
move
want
on.
your goroutines to never fail.
Well,
If you just write perfect code, you don't have to do error
and
handling.
it's not that I want them to never fail. It's that I want them to be so unimportant that if they do fail, it doesn't affect the rest of the system. It's, again, imperfect.
I saw a question, but I didn't get to read all of it by Anthony Atkinson. Can you repeat that?
That was the one Venkata repeated about limits and bottlenecks.
Perfect.
So. Awesome. Well, we won't back this out. This is a great example of like these standard lib talks. Don't like come give them, right? Like they don't have to be super involved. You don't have to have a big dissertation on the package. I probably would have put one smaller package in with this one if I'd, if we'd known. So just to have people, if you're going to come here, have a little bit more value out of your time. But thank you, Venkata. This is really good. I think that, yeah, thank you for coming and put this together. And we have, I think, somebody volunteered to talk about clean shutdowns. Roman.
Yeah, I can do, I've been working on a personal project and
Meridians are always welcome remotely.
the idea of graceful shutdown on demons is really resonating to me. So I'd like to maybe present on it.
So we'll break a little bit from standard lib next month to talk about, and cause this is a pretty low, I'm trying to keep the meetup to low level, non-obscure problems. And I think gracefully shutting down a server without just killing all the in-process like requests is a pretty important thing that is good to learn fundamentally. That we all have a pretty good chance of writing an HTTP server where you don't want to just shut it down before you finish serving the client requests. So we'll break a little bit from that, but just to reiterate, the Go channel, if you're on Utah Go or Forge Slack, if you're not on Forge Slack, it's forgeutah.tech. Join that and come chat with us in the Go channel. If you're in that channel, there's a canvas that you can follow in Slack that where we've listed out all of the standard lib packages. And I would love to have another few meetups later on in the summer. We have it all open basically after June and have people come talk about. There's simple things like font or time, which isn't simple, but Go has made it generally pretty simple to cover. So yeah, please don't feel like you have to be an expert. I want to get as many people up and talk about these low level packages because I think it's been really nice to come to some meetup and like talk about some stuff that we all can grasp, but you don't have to have 20 years of engineering context to understand. So